This shouldn't be happening. The mystery of Comet 29P. Something strange is happening in the outer reaches of our solar system. Just beyond Jupiter's orbit, a single object has been exploding again and again for decades. No warning, no pattern, no clear cause. It brightens by hundreds of times within hours, ejects over 1 million tons of debris, and then falls silent until it happens again. And here's the strangest part. This isn't a comet approaching the sun. It isn't being torn apart by gravity or heat. It's just floating out there, in a nearly perfect circular orbit, behaving like nothing else we've ever seen. So what's really happening? Is it alive in some strange geological way? Is there something inside, something we've missed all along? And could this mysterious object be the most active volcanic body in our entire solar system, second only to Jupiter's moon Io? Today, we dive into the mystery of Comet 29P Schwassmann-Wachmann, also known as Centaur 29P. Why does it erupt so violently? And what has the James Webb Space Telescope recently revealed that's forcing scientists to rethink everything we thought we knew about icy bodies in space? Let's find out. The discovery, a centaur among giants. The story begins almost a century ago. In 1927, two astronomers at the Hamburg Observatory, Arnold Schwassmann and Arno Arthur Wachmann, discovered a faint, slow-moving object while comparing photographic plates of the night sky. At first, they thought it was an ordinary short-period comet. But as time passed and its orbit became clearer, the classification changed. 29P wasn't like other comets. It didn't plunge toward the sun in a long elliptical path. Instead, it stayed between the orbits of Jupiter and Neptune, tracing a nearly circular route around the sun every 14.6 years. That placed it in a strange category known as Centaur objects named after the mythical half-human, half-horse creatures of Greek legend. And the comparison is fitting. Centaurs are hybrids part asteroid, part comet. They originate in the Kuiper Belt, far beyond Neptune, but gravitational nudges from the giant planets occasionally drag them inward. Once that happens, they become unstable transient visitors to the inner solar system, destined either to fall toward the sun or to be ejected into interstellar space forever. Most centaurs are quiet, frozen, dim, but 29P is something else. It's one of the largest centaurs, known about 60 kilometers across, wider than 96% of its kin, and it's one of the most active objects in the entire solar system. It erupts on average 30 times every year, and 40% of those explosions happen without any warning or pattern whatsoever. No other known comet behaves like this. It's like a cosmic volcano, erupting in the darkness between worlds. The explosive mystery. Each outburst is dramatic. Within just 2 or 3 hours, 29P can become hundreds of times brighter. Sometimes it bursts 4 times in just 2 days. In 2024, it did exactly that, 4 eruptions in 48 hours, making it nearly 300 times brighter than usual. 2 years earlier, it expelled more than 1 million tons of debris into space at supersonic speed. Imagine the most pressurized champagne bottle in the universe being uncorked. And that's not all. Often, one major explosion is followed by 2 smaller ones. About 5 to 7 days later, as if something underground continues to rumble long after the main blast. Astronomers have recorded dozens of these events, but the largest on record happened in September 2021, the most powerful eruption in 40 years. And who first spotted it? Not professional astronomers, but amateurs. Enthusiasts with backyard telescopes saw it flare up before observatories even knew something had happened. That's part of 29P's strange charm. It's unpredictable, and yet so visible that skywatchers across the world can catch it in action. Professional observatories then scramble to study it, fighting for precious telescope time, because who would approve a multi-million-dollar space observatory to watch an object that explodes at random? But sometimes luck is cruel. Just one day before Hubble was scheduled to observe 29P in 2021, it malfunctioned. The telescope went offline, missing the show entirely. Cryovolcanism, the ice volcano theory. So, what causes these outbursts? If you're thinking volcanoes, you're not far off, just not the fiery kind. 29P is what scientists call a cryovolcanic comet, an object covered in ice, with volatile gases like carbon monoxide and carbon dioxide, CO, trapped beneath its surface. Over time, sunlight penetrates the outer shell. It warms the interior just enough to make some of that ice sublimate transform directly from solid to gas. Pressure builds beneath the surface, and eventually, boom, the crust fractures, and jets of icy gas erupt violently into space, carrying dust, frozen water, and other materials with them. That mixture cryomagma is essentially a cocktail of frozen ammonia, water, methane, and nitrogen. It's beautiful and terrifying. Now, you might wonder, why doesn't this happen in all comets? The answer lies in 29P's gravity and rotation. Its escape velocity is relatively high, meaning not all of the ejected debris escapes into space. Much of it falls back, reforming the crust after each eruption, essentially resetting the system for the next explosion. That could explain why smaller eruptions often follow big ones. The surface collapses under its own debris, sealing the cracks, until pressure builds again. A self-repairing cosmic geyser. The circular orbit problem. But there's a problem. Most cryovolcanic comets orbit the Sun in elongated ellipses, which means they heat up dramatically as they approach their closest point, triggering eruptions. 29P doesn't. Its orbit is nearly circular. It stays the same distance from the Sun all year round. That should mean stable, predictable heating and no sudden explosions. And yet, it behaves like a ticking bomb. Why? Why does it erupt so violently when it shouldn't? For years, scientists have tried to find a pattern in its madness. Some noticed that large eruptions often occur roughly every 57 days, matching its rotation period. Could it be that sunlight periodically hits a volatile patch on its surface as it spins? Maybe. But smaller eruptions also occur every 30 or 90 days, too irregular to fit a perfect cycle. It's almost as if the comet has seasons, internal pressure cycles, or hidden fractures deep within. A breakthrough prediction. In April 2023, something extraordinary happened. Astronomers noticed that 29P was dimming its gas emissions, slowing down. They suspected that pressure might be building inside. They made a bold prediction. It's about to erupt. And that same day it did. A small explosion, perfectly timed. It was the first ever successful prediction of an outburst from this chaotic object. For the first time, we weren't just reacting to the randomness, we anticipated it. Science had finally caught up to the madness of 29P. Enter the James Webb Space Telescope. But the real game changer came in 2024. For years, scientists believed that carbon monoxide gas was the primary driver of 29P's eruptions. After all, CO is extremely volatile. It turns from ice to gas even at -248 degrees Celsius. But the James Webb Space Telescope changed everything. Using its near-infrared spectrograph, Webb observed something no one had ever seen before. Not one, but two jets of carbon monoxide, one pointing toward Earth, another toward the north. And in addition to that, Webb detected two separate jets of carbon dioxide, one to the north, one to the south. This was the first definitive detection of CO on 29P. This dual jet structure suggested something incredible. 29P might not be a single uniform object. It could be a fusion of multiple bodies, stitched together in a slow cosmic collision eons ago. Each fragment might retain different ices, compositions, and internal structures, each capable of erupting independently. That would explain the unpredictability. It's not one volcano, it's dozens, each waiting for its own turn to blow. The amorphous ice hypothesis. But Webb's data also led to a deeper puzzle. Why is there so much carbon monoxide trapped beneath the surface when it should have escaped millions of years ago? Here's one fascinating possibility: amorphous water ice. On Earth, ice is crystalline, its molecules neatly arranged in repeating structures. But in the freezing outer solar system, water freezes differently. At temperatures below 77 Kelvin, -196 degrees Celsius, it forms amorphous ice, a porous, chaotic structure that can trap gases within it. When that ice warms and becomes crystalline, the trapped gases are violently released. If 29P still contains large pockets of amorphous ice, each region could act like a time bomb, waiting for enough warmth to trigger conversion and an eruption. A matter of scale. Here's where size becomes everything. Smaller Centaurs, just a few kilometers across, would have long since converted all their amorphous ice into crystalline ice. That process takes only a few million years. But 29P is massive. Models suggest it could take 60 to 100 million years for all its amorphous ice to fully crystallize. At its current location, only about half of it has done so. That means half of its interior is still unstable, full of trapped gas under pressure. Each patch that crystallizes could release sudden jets of CO, cracking the surface, shaking the crust, and hurling debris into space, over and over again. And when parts of the surface collapse back down, sealing the fissures, the cycle begins anew. The chaotic heart of 29P. Some scientists suspect that these structural changes, collapses, sinkholes, and landslides inside the nucleus may be the real engine behind its unpredictable nature. But there's still something missing. Even if crystallization explains the gas, how does the pressure build up so quickly enough to cause multiple eruptions a year? The truth is, we still don't know. 29P refuses to fit into any of our models. It shouldn't behave like this, and yet it does. Perhaps deep beneath its frozen crust, a slow, rhythmic breathing occurs. Pockets of ice melting, refreezing, collapsing again. A kind of heartbeat in the darkness. The cosmic significance. Why does any of this matter? Because 29P might be showing us how the early solar system behaved, when ice, rock, and volatile gases interacted chaotically in the cold frontier beyond Jupiter. Studying it helps us understand planet formation, cryovolcanism, and the strange chemistry that might one day lead to life on other icy worlds. In many ways, Centaur 29P is a living fossil of the solar system's infancy, a frozen relic that still moves, still breathes, still surprises us. And thanks to telescopes like Webb, we're finally peeling back its layers one explosion at a time. The final mystery. Why does it keep erupting? Why so violently, so often, so unpredictably? Every answer only leads to more questions. Is it possible that 29P isn't just a remnant of the past, but a preview of the future, of what will happen when our own icy worlds begin to die, fracture, and vanish into the dark? Perhaps what we're witnessing isn't chaos at all, but transformation. Maybe this is what happens when a world tries to hold on, when trapped energy from the dawn of the solar system still struggles to escape. So what do you think? Is 29P a single unstable comet, or a cluster of icy fragments colliding from within? Could amorphous ice really explain its wild behavior, or is there something even stranger we haven't discovered yet? Let me know what you think in the comments. Because somewhere beyond Jupiter, a lonely world keeps exploding in silence, and no one truly knows why. Thanks for watching. If you enjoyed this deep dive into the mysteries of our solar system, subscribe for more stories that remind us how little we really know about the universe we call home. See you next time under the same silent stars.